Welcome to class. This lesson is over prime factorization. Let's look at our number routine. Our number routine says put these rational numbers from least to greatest. Again, a rational number is anything that can be written as a fraction or a decimal form. So it goes for our number line goes from least to greatest. Well, what type of numbers do you see on the least side? Usually negatives. What type of numbers do you see on the opposite side? The greater number, positive. So let's start moving things. Well, these two are negative, so I'm going to put these here. Well, 0 will have to somewhat go right here in the center, I assume. These are positive. So let's start with the positives first. Well, that's 45%, so I'll put it right here. 0.3. That's 3/10. What's 3 groups of 10? Hopefully you'll say 30. So let me get my pen. So 3/10, how do you put it to 100 times 10? So it's 30%. So it goes right here. And 3/2. If I build this to 100 times 50 times 50 does 150%. It's more than a whole. So now let's look at this. This is negative 5% and negative 2/5. So negative 2/5. How do I build this to 100 times 20 times 20? That's negative 40%. So in a negative one, negative 40% would be farther. I don't know why it's not working. So negative 40% would be farther away from 0 than negative 5%. So this is our answer. Negative 2/5, negative 5%, 0, 30%, 45%, 150%. All right, so today we're going to be learning how to factor. So let's go. How can we multiply to get the following? Let's start with 2. How can we multiply to get 2? 2 times 1. So to get 2, you need to multiply by 2. So we'll just put it right here. How can we multiply to get 3? 1 times 3 or 3 times 1. But we're going to skip the 1 because this is, and we're just going to use 3. To get 3, you multiply by 3. What do you multiply to get 4? I could say 4 times 1. But do you know a way to break down the 4 into another way? What about 2 times 2? So 2 times 2 makes 4. So we're going to write this down as 2 times 2. You could write it this way, but you know what? I'm going to write it with a multiplication dot. 2 times 2. And now today we're going to be learning something called exponents as well. So what number are we multiplying by? 2. How many 2s you see are being used as a factor? Twice. So it's 2 squared, or 2 to the power of 2. 5. How can we multiply to get 5? 5 times 1 or 1 times 5. So we're multiplying by 5. How can we multiply to get 6? Well, you could say 6 times 1, but can I break down 6 times 1? How would you break down 6 times 1? Maybe 2, and then we're going to put 3 on top of it. 2 times 3. So what factors make up 6? 2 times 3. Or I need to start writing it with the multiplication dot. So you know what? I'm going to erase the other one, and it's 2 times 3. 7. How can we multiply to get 7? 7 times 1, or just 7? You know, I'm going to stop right here. Why is it, and here's my question right here. Let's pull this out. Why do certain numbers have only one single factor? For example, 2, 3, 5, and 7 only have one single factor. Think about what you remember from last year. What type of numbers are those called? Hopefully you'll said, oh, those are called prime numbers. Last year you learned something called prime and composite. 2, 3, 5, 7, including 11 and 13, are prime factor. Prime factors are numbers that can only be multiplied one times itself. So prime factors. While the opposite of it is called composite. Composite has multiple factors to work with. For example, 4 has multiple factors like 2 times 2, and like 6, 2 times 3. All right, 8. How can we multiply to get 8? 4 times 2 or 2 times 4. Those are called cumulative, but those are the same thing, so we'll just say 4 times 2. Is there another way to break down a 4? Let's go back to refer back to this box. How would you break down that 4? Oh, it's 2 times 2. But then I said 4 times 2. So 4 is represented, what, 2 times 2, and then we have another 2 right here. So how can we represent this? Multiplication dot. 2 times 2 times 2 is 8. But let's write it using exponent. It's 2. The factor, what factor do you see? 2 is repeated 3 times, so you put a little 3 right there. It's called exponent. 2 to the power of 3. We also call it cubed. Next number is 9. 9. How can we multiply to get 9? 3 times 3. Oh, 3 times 3. So I'll put it 3 times 3. And let's write it down. It's 3 times 3. 3, and let's write it using exponents. How many times did the factor 3 repeat itself? Twice. So it's 3 squared. How can we multiply to get 10? 2 times 5. Whoops. So we have 2 and times 5. And so what factors make up 10? 2 times 5. Let's go back to 8 again. Let's talk about 8. Are there different ways to say 8? For example, one way to say is, what's 2 times 2? 4. 4 times 2 is 8. Could I say it as this? Whoops. Can I say it as 2 times, and what's 2 times 2? 4 is 8. So for 8, can 4 be broken down again? Yes, 2. So we can say, we multiply the first 2 pairs. That's 2 times 2 is 4. 4 times 2 is 8, or 2 times 4. All right, let's continue on and finding our factors of the following. 11. How can we multiply to get 11? Just 11 times 1. So you know what? I'm going to move it right here. 12. How can we multiply to get 12? 6 times 2 or 4 times 3. If you're going to choose 6 times 2, let's go back to our previous screen. 6 is made up of 2 and 3, so let's make sure we use that. So 6. So 2 times 3 is 6. 6 times 2. And those are the factors that make up 12. How can I write this down? 2 times 2 times 3, or 2, how will you write it as exponent? Square times 3. 13, how can we multiply to get 13? Just 13. How can we multiply to get 14? 2 times 7. And so let's write that down. 2 times 7. Can I write it using exponent? I cannot. 15. How can we multiply to get 15? 3 times 5. How can we multiply to get 16? Now this is where it takes a little more thinking. So 16. How can we multiply to get 16? There are several ways you can multiply to get 16. You can say 2 times 8. Maybe you rather say 8 times 2. Maybe you rather say 4 times 4. So which one do you want to use? 4 times 4? Fine, we'll use 4 times 4. So let's go back to our table. 4 is represented by 2 times 2. So let's right here. So 2 times 2. So 16 is 4 times 4. And then another 4 is represented by another 2. And so 2 times 2 times 2 times 2. How would you write this using an exponent? 2 to the 4th power. So what are different ways you can say 16? Well, different ways you can say 16 is the following. For example, If I make the 2 by itself, it could be 2 times 2 times 2 times 2 is 8. Or you could put this right here and say 4 times 4 is 16. Or you can put it right here. You can say 2 times 2 times 2 is 8 times 2 is 16. Another way to do it is we're going to be learning something called factor tree. So 16 can also be written as, if you cannot break it down using the table, this is another way you could break it down, 16. What are the factors 16? We could say, what we chose earlier was 4 times 4. So we make a branches. So you write 16 and you draw 2 little branches. And what are the factors of 16? 4 times 4. Can 4 be broken down again? Yes, it can. It can be broken down by 2 times 2. So you circle these 2 so that these are the factors that make up 16. What about this 4? Can this 4 be broken down? Yes, it can be broken down in 2 times 2. And so we see a 2, 2, 2, 2, 2, 2, 2, 2, or 2 to the 4th power. All right, next one, 17. How can we multiply against 17? I think it's just 17. So we're just going to write 17 now instead of using these tiles. 18. How can we break down to get 18? We could say 2 times sign. Okay, let's do 2 times sign. So we know 2 is right here. Let's move the 2 here. But 9, I'm going to refer back to previous. 9 is represented by 3 and 3. 3 times 3, so 3 times 3. So how can we represent this? It's 2 times 3 times 3. How can you write it as an exponent? 2 times 3 squared. All right, 19. How can we multiply to get 19? Just 19. How can we multiply to get 20? Let's see. 4 times 5. How is 4 referred back in this table? By 2 times 2. So 4 is represented by 2 times 2, and then times a 5. So we see a 2 squared times 5. 21. How can we multiply to get 21? 3 times 7. 3 times 7. How can we multiply to get 22? 2 times 11. How can we multiply to get 23? I think it's just 23. And now let's do a hard one. 24. How can we multiply to get 24? Many ways, many factors that make up 24. I'll try 4 times 6. If I go back to my table, I see 4 is represented by 2 times 2. And 6 is represented by 2 times 3. And we'll put the 3 here. And so 24 is represented by 2. 24 is represented by 2 cubed times 3. Are there other ways to say 24? What about this? So we have 4 times 6. What if I put the 2 separate? So 2 times, what's 2 times 2 times 3? 2 times 2 is 4, times 3 is 2 times 12. What about if I did it, whoops, this way? 2 times 2 times 2 is 8 times 3 is 24. Again, I could do 4 times 6 is 24. And now 25. How can we multiply to get 25? 5 times 5. And how can I represent that using an exponent? 5 squared. All right, 26. How can we multiply to get 26? 2 times 13. How can we multiply to get 27? 27. 27, the factors are 3 times 9. So going back to our table, how is 9 represented? By a 3 times 3. And how would you write that using exponent? 3, and it's 1, 2, 3, cubed. Next one, 28. How will you represent 28? Several ways you could represent 28. I'll try 4 times 7. How can we break down 4? 4 is 2 times 2. and that's 4 times 7. But what is another way you could have broken it down into? Well, what if I did it this way? 2 times, and what's 2 times 7? 14. That's another way I could have broken it down. So these are all different equivalent ways of breaking it. So how would you write this as exponent? 2 squared times 7. How can I represent 29? I believe it's prime, so it cannot. How can I represent 30? Many ways. I'll try 3 times 10. So I see a 3 right there. And then 10, how is 10 represented in this table? 10 is represented by 2 times 5. So we have a 2, 3, and 5. So how would you write this out using exponent? Just 2 times 3 times 5. It does no factor to repeat itself. How can I represent 31? I believe it's just going to be 31. How can I represent 32? 4 times 8. And what is house 4 represented in this table? 2 times 2. And how is 8 represented in this table? I believe it is 2 times 2 times 2. Oh, God, that's a lot of 2's. So that's 2 to the 1, 2, 3, 4, 5, fifth power. But what are different ways you can say, because we tried 4 times 8. What about this one? 2 times, and what is 2 times 2 times 2 times 2? 16. So another way you could say is 2 times 16. Another way you could say is 2 times 2 is 4. 4 times 8. All right, 33. How can we represent 33? 3 times 11. How can I represent 34? 2 times 17. And 35, 5 times 7. Now 36, how would you break down 36 down? 6 times 6. If you go back to our table, how would you represent 36? 6, 2 times 3. That's 6. And then 2 times 3 again. So how would you say this as an exponent? 2 squared times 3 squared. So I said 6 times 6. But could I say as 2 times 2 is 4 times 9? Could I say as this? 2 times 2 is 4 times 3. 12 times 3. So there are multiple ways to say each factor. 37, all right, not all, except for prime number. 37 is just 37. 18 is 2 times 19. 39 is actually 3 times 13. And the very last one, 40. How can I represent 40? 5 times 8. So 5, and I forgot how to break down 8. 8 is represented by 2 times 2 times 2. So, dot, dot, dot. So, how would you write an exponent? 2 cubed times 5. But what are different ways you can say 40? I said earlier 5 times 8. What about 2 times 2 times 2 is 4. 4 times 5 is 20. 2 times 20. What about 4 times 10? Those are different ways to say 40. So this is a study of prime factorization, of breaking numbers down into prime numbers and using exponents.